4.1. Here the author is trying to introduce a little economy into the algebra. So we have some variables to define here. So we'll just do this real quick. Quantity supplied is a good, or excuse me, let me say it again. The quantity supplied of a good is the amount of a product that a company is willing to make available for a sale at a given price. Okay, so this is all about the company supplying the quantity. Quantity demanded, that's going to be all about the consumer. The quantity demanded of a good is the amount of product that the consumers are willing to purchase at a given price, which makes sense that if the price is way too high, no one's going to buy it. Then they have excess inventory. All right, what do? They put it on sale. Really lower the price. Now it's on sale, people are going to snag it up. Equilibrium price. This is the price of the product to be defined as the price at which quantity supplied, that's what the company's willing to put out for quantity, equals the quantity demanded. So in other words, this is the price where the company is looking for that perfect price so they can sell their entire inventory that they have to get the best amount of revenue. Equilibrium quantity, okay, this is going to be how much they want to have for inventory to be sold. This is the supply. This is how much product that needs to be created for that equilibrium price. All right, so looking at an example. Suppose that quantity supplied S and quantity demanded, we'll call that capital D, of gaucho dogs at a football game is given by the following functions. Your supply at a given price, P, is equal to negative 20 plus 30P. Your demand, D, of price P is equal to 100 minus 10 times P. Again, P will be the price of the gaucho dog. Find the equilibrium price for the gaucho dogs at the football game, and then we'll find equilibrium quantity. So that means we're just setting to find the equilibrium price. We got to solve for P by setting these two functions equal to each other. So negative 20 plus 30P is equal to 100 minus 10P. All right, let's start moving terms. Negative 10P, I'm going to add 10P over to the other side. Cancels out. Get rid of the minus 20, add 20 to both sides. I'm going to add that to the 100. So 30P plus 10P is 40P. 100 plus 20 is 120. Divide by 40. The equilibrium price is $3. So if I'm going to have this price of $3, all right, I need to know how many of these gaucho dogs I need to have at the concession stand. So we'll just take the $3 for that price and we'll substitute it into either one of these two functions. Again, what we're finding is where these two linear function lines of their graphs are going to cross each other. So S of 3, it has to be equal to D of 3. It doesn't matter which one you're going to solve. I went with S only because the P term was positive and I like to stick with positive terms. So negative 20 plus 30 times 3, well, that's 90. Negative 20 plus 90 is 70. I need to have 70 gaucho dogs ready to go in the concession stand. All right, determine the price for which quantity demand is less than quantity supplied. Now we can do this algebraically. So quantity demand, that's D, so D of P has to be less than quantity supplied, S of P. All right, well, I can't just look at what's up here and say, let's just put a less than symbol. The price is less than $3. because in this one I started with P, S of P on the left side. Now D of P is on the left side with a less than symbol, so it really matters when we deal with these inequalities. All right, now a visual approach is to look at these two functions and make a rough graph. Now we're pretty smart. We know that, okay, the constants in a linear function is your y-intercepts, and the number multiplied to my p, that's my slope. So if I made a quick graph, we'll choose S of P be in red, D of P will be in blue. P is the independent variable, that's my price, that goes on the x-axis. All right, if you will, my gaucho dogs are here on the y-axis. So we want to know, when is D of P the blue graph? When is the blue graph less than the red graph? So here the intersection, they're the same, but once I go past that intersection, which is 370, that intersection point is 370. After $3 price, now the blue line is below the red line. That's when I have quantity demand less than quantity supplied, is when the price is greater than $3. So if you sell for more than $3, you're going to have leftover gaucho dogs because they're going to be priced too high and you're not going to sell as many. All right. Now again, you could do this algebraically, but if you can make a quick graph, here's 100, way up here, negative slope going down. It doesn't have to be precise. Negative 20 for a y-intercept, positive slope. When you find that equilibrium price up here and the quantity, that point is 370. Now you can use the graph to handle any inequality question. All right, so what do you think will eventually happen if the price of the gaucho dog, if quantity demanded is greater than quantity supplied? The demand, all right, that's the D, is bigger than S. Well, if demand is ever greater than supply, all right, that's the, let's see, what's my colors here? Demand, that's blue. It's going to be greater than supply. You always increase the price of your gaucho dogs. All right, think of it this way. You've got 5 hot dogs left and there's 15 people who want the gaucho dogs. All right, who's willing to pay a higher price out of those 15 people? Then hey, let's have a bidding war. Okay? All right, next example. In 2002, Major League Baseball signed a labor agreement with the players. In this agreement, any team whose payroll exceeded $136.5 million in 2006 had to pay a luxury tax of 40% on any salary that exceeded $136.5 million. So that was the salary cap at the time. Write the linear function that describes the luxury tax, capital T, of a team whose payroll was P in millions of dollars. Okay, so T of P equals 40% converted to a decimal, 0.40, times the payroll minus the 136.5. So this is only going to be a function whose domain is greater than the 136.5. So if my payroll was 100 million, well, 100 million minus 136.5, that's negative 36.5. They're not going to pay me money back for being below the salary cap. All right? So this is for anything that goes over the salary cap. All right, next question. What was the tax for the New York Yankees whose 2006 payroll was $171.1 million? They're over the cap. So we'll take our function, put in 171.1 in for the P. All right, so 171.1 minus 136.5. Calculator says it's 34.6. Multiply that by 0.40 for the 40% tax. That's 13.84 million. So you have to add that tax on top of the payroll. So in essence, the Yankees almost spent $185 million. This would be 184.94. This payment goes back to the league. And all, from what I understood, all these luxury taxes collected by Major League, and this money was sent out to the smaller markets. Okay, what is the payroll of a team that pays a luxury tax of 11.7 million? Okay, so now we know what the tax is. We have to figure out what's the payroll. So we're going to work this backwards. So set the function equal to 11.7 and solve for P. Well, don't distribute the 0.40. I say divide it into the 11.7 first. Okay, so let your calculator will do that. Come on, calculator. 11.7 divided by 0.40 is 29.5. Now the parentheses are gone. We can add over the 136.5 to the 29.25, and the payroll was, whoops, come back here, 165.75 was the payroll. All right, and that takes care of the part 3 video.